resistance in series with it. And then I reconnect it to the circuit right there. How many see this? Down here, guys, you follow me on that? That's a source transform. This is a Thevenin equivalent of this being a Norton equivalent, and this is the voltage, Vs, right? It would be. Now you can do it that way. I'm going to tell you all the ways, all right? So does everybody follow me? If I replace this part of the circuit with that, maybe I should do it right here real quick. Just down here so I can discuss this. Some people will not ask questions, and I'll try to assume you have a question even if you're not asking. We'll do ideal diodes. And now I replace this part of the circuit with whatever that R is, 3K. And then I have the voltage source here of plus to minus 6 volts. And Vs here is 2 volts, right? Now that's perfectly legit if you're after I1. You all follow me on this?
Yes.
Now, yes, sir.
I just want to make sure the voltage, the new voltage has opposite polarity. So it's it has opposite polarity of the main voltage.
Well, yeah, in this case it does. It doesn't have to, but in this case it does. Now, if you think about this, and you follow me on this? The simple way to think about this. The 6 volts wants to push current that way, correct? The 2 volts wants to push current that way. 6 is greater than 2. The effective voltage pushing it counterclockwise would be 6 minus 2 or 4 volts. Do you all see that? Let me see your hands if you do. I got to make sure I'm talking to people that understand. It's not hard to see, but you have to make sure you see this. So therefore, current would like to go this way. Can it go that way? No. No current flows at that point. You all follow me? Now here's the final way to do it. Well, I'm going to leave this as I1. Maybe you get confused. Maybe the circuit's too complicated. So here's what you do. Pretend this diode is a short circuit. And some people will do this. Here's where the diode's a short circuit. Now analyze that circuit and find the direction of I1, either that way or that way. You all follow me? If I1's going that way, it can go that way. The diode's a short. If I1's going this way after the analysis, you can turn it into an open circuit that's disallowed. Now those are the 3 typical easy ways to do it. And you pick the way you want to do it. By this time, if you've done these problems, you start seeing what you need to do. I'm leveling it. That's the way it usually happens. Diode problems, they're either on or they're off. It's that simple. There is no meta state. It's one of the 2 conditions. You have binary, I'm asking a question. You know, do you have something where you get the threshold of either shear or strain where something will rip? I don't know how you teach that in mechanical engineering, but there comes to a point where something is either going to be torn in half or it's not, or tear apart. That's the same kind of deal. It's either going to be one thing or the other. It can't be in between. There's no possibility. We go to that? All right, now that was for Vs equal to what? 2 volts? Did they ask for another Vs?
12 volts.
All right, let's talk about 12 volts. And I'm going to put the dial back and disconnect this. I'm going to use an ideal diode right here too. Okay? Yes, sir.
There was also an I2 closed with 3 kilo ohm resistor.
Yeah, and what would that be, by the way, for the first part? It has to be, right? No current flows this way, but there's 2 milliamps. That has to flow down there. You all follow me? Just Kirchhoff's current law right there. Whatever goes into comes out. What's going in is 2 milliamps. Nothing can come out that way. Everything goes that way. Follow me? How many see this? All right. Now, next question is this. So Vs for the second part, and we can do non-ideal in a second. Now, if it's non-ideal, is it going to matter for that case? It doesn't matter if I have a threshold voltage to overcome. I can't even get the thing going if it's ideal. So the threshold voltage stuff you can throw out. Ideal or non-ideal, no current flows when Vs is 2. How many see that? Down here, guys? Francis, you got it? All right, next step, VS is what? What? 12 volts? I bet you guys do. If it's 12 volts, we know if it's disconnected, right? I tell people not to do that. No, we got 6 volts here, correct? But we have 12 volts here. Can you see that the 12 volts will push current in that direction because it's greater than 6? How many see that? With me on this or not? People, y'all with me? All right, if you see that, you basically got a handle on this stuff. You're starting to inspect things and you're getting an idea of how you go about business. Basically, if that diode's on, it's a short circuit. What does that mean? Well, if it's on, I could replace it with the short, do the analysis, and if current's going in the direction it's allowed, it's a short. If it's going in the direction it's disallowed, it's an open. Just cut the wire out, you might say. Follow me? That's it. Now, well, actually, they want the values of current. So if this is, basically that diode's on. Do we all agree with that before I continue? So if we want to get, and I don't care how you do this, if I make this a short circuit to help you see it, how are you going to get I1 and I2? There are lots of ways to do it. Look, to save time and pain, I'm not going to go through everything, every possibility, but I see a pretty easy way. We got a node here. There's got to be a voltage on this node. You all see it? I'm trying to make it absolutely clear. That diode's on, right? We'll call that V1 right there. With me? Now we can do nodal analysis. I1 equal, or I1 plus 2 milliamps equal I2. Do you agree with that? Over here, guys. Francis? We can do that. Once we do that, we can figure out what V1 is. Do you all agree with that? If we have V1, we can get I2 by dividing V1 by 3K, right? And if we have V1, we can go ahead and say VS minus V1 divided by 1K would be I1. How many see that? I don't want to waste time today. Do you all see it over here? Your head's tilted like this, like I don't believe you. I'm trying to be honest, trying to be as clear as I can. And I know some of this stuff can be irritating because it's a little confusing when there's so many possibilities. You get 3 or 4 diodes in a circuit, you start scratching your head. All right? But it's all basically coming down to analyze a circuit in all possible ways. Like for 2 diodes, both off, both on, one off, one off, one on. And it'll start becoming clear to you what's possible. Y'all with me? All right, so for this one, if you wanted to do it with nodal, because the diode is on, we would say I1 right there plus 2 milliamps is equal to I2. I want to be clear about this. First, do you agree with that? Now you replace the unknown currents with unknown voltage, the V prime, or I'm calling it V1 there. So now I'm going to say I1 right there is going to be 12. The VS is 12, so it's going to be 12 minus, in this case, V1 over 1K plus 2 milliamps equals I2, and I2 is just V1 over 3K. Now I'm just doing this as simply as I can. Do you all agree with this, class? What I usually do at a point like this, I'm going to multiply by first 1,000 to get rid of the K. All right? And that gets rid of the milli here, right? And that makes this amps. Do you all agree with this, class? And after that, the only thing I'm going to do, and it's up to you, I have to get V1 on one side, the other thing. If I multiply by 3, I'll just do it quickly. 3, this becomes 6, right? Y'all follow my thoughts on this one? I'm just trying to get it into an easy form to analyze. And then, when I go ahead and do this, I'm going to get 36 minus 3V1 plus 6 is equal to V1 right here. And then I take the minus 3 to the other side, I get 4V1 is equal to 36 and 6 is 42, or 42 over 4 is V1. Are we in agreement? So far? And you can get the currents that way. How many see this? Okay. What would the difference be? This is the thing I'm going for. What would the difference be if it was a non-ideal diode in this analysis? First, let me ask you this. Would the diode be on? That threshold to overcome is 0.7 volts, right? If it's 0.7 volts, I got 12 pushing it that way, and I have effectively 6 pushing it this way, right? It can be overcome. Do you agree with this? But what you need to do is put a small voltage right here that would be plus to minus 0.7 volts if it's not ideal. You can replace the diode with a short circuit. How many understand it? Because it's on, right? Do we agree it's on? And then you can go about the analysis. What's the only thing that would change over here? It would still be, and I erased it, but this would still be I1, right? That would be I2, that's still 2 milliamps, so this equation, the top one still holds. Does everybody agree with that? Guys in the back, can you see this okay? Maybe I can't see you okay. All right, the only thing that changes is what here, right? Well, I'll get rid of the 3, make that 2, make that 3, and let me just talk my way through this, and I think you can see. Now instead of 12 minus V1, right, it's going to be 12 minus V1 plus 0.7. How many see that? You're going to have to account for the 7/10 of a volt. Do y'all see it? You have a troubled look. Do you see it?
I want to make sure the V1 plus.
Here's what I'm talking
0.7
about.
in parentheses, right? So
Look,
it's
the
12
voltage
minus
across the 1K is what? Well, it's V1 plus 0.7 on that side, and it's VS on that side. So VS minus V1 plus 0.7 over whatever that is, 1K. Agreed?
Yeah.
Okay. You good with that? Anything else troubling you? Any other questions besides the thermo test? Good luck. That was a tough course for me. I remember that course. I've never been a fan of pages. Okay. So I assume you've done the homework, and I assume you've gone through all the permutations, because I gave you a wide variety of problems that make you reason through. I gave you plotting problems, gave you everything, right? Somebody's going to ask something to the effect of, are we going to have to plot something on the quiz? No. You're going to have to analyze it, though, and get values. Follow me? So it's going to be discrete, basically things you fill in. On the final exam, I may ask for something where you plot an output voltage versus an input, but not on this quiz. You got that? So don't just rule it out. And diodes will be in some way, shape, or form on the final exam. All right, now I want to cover one thing until he arrives, because I know you're desperate to get that quiz so you can go take your thermo test. By the way, is thermo closed book closed notes or not?
Depends on your professor. It's open.
Open notes or open book?
Open.
Open book.
No, no.
That's it. Oh, he doesn't want to copy the Steam tables, probably. All right, now hear me, guys. I've got to go through this. If I can have your attention, I'll be good to you. You be good to me. It's that simple. I want to do 1 or 2 problems based on what I talked about last time. I'm assuming a lot of you didn't do them, which is not good, but expected. I used to give, it didn't matter how much time I spent on it, but I'd give, like, if I covered transistors one day, you would get it on the quiz, regardless how much time. I don't do that anymore. So what I'm going to do is find when I get some more. What? If you want it, I'll put one on. I'm going to do one, just hear me. I'm gonna do problem 1139. And I'm gonna talk about a couple things. All right. They have a thing, and they have a statement, just listen to me. They say, determine the Q point. That's called the quiescent point. It's what values of current and voltage would occur in this circuit. Y'all hear me? Now this is called DC analysis because there's nothing time varying. I'll get to it more. And what they want is this, and they say beta, or the current gain in this one, is 120. All right, so this is, everything here is extremely reasonable, common, something you might run into in terms of values. I have a statement, I want you to listen to me. You see this capacitor right here? It really doesn't matter what the value is. What does a capacitor look like if there is no time varying voltage, if it's a DC voltage or a DC current? What can you replace it with? Anyone? An open circuit, right? A capacitor has a reactance, if you want to think about it in the frequency domain, as 1 over j omega c, right? DC means the frequency is 0, or it's 1 over 0. That's infinity. Infinity is an open circuit. It's two wires dangling, or basically 2 points with nothing between. Y'all follow me on that? So this is an open circuit to DC. You don't even need to consider that here. It's nothing. With me? It'll couple the AC signal when you go through that part of the analysis, but right now it's nothing. So when you do this, now listen carefully because people will mess this up. The current, all the current flowing down here has to go into the base because it can't flow through that capacitor. That's called the base. Do you all remember that? The middle point? This is the emitter, this is the base, and this is the collector. This would be the base current. All right? Now, if the transistor is operationally on, and in this case it's got to be, if you've got 10 volts there, you're going to get a voltage drop. I got to give myself a little more room. We're going to call this IB. You're going to get a voltage drop plus to minus 0.7 volts for a silicon transistor, which is 99.9% of all the transistors in the world today. All the VLSI stuff in your phone, laptop, it's based on silicon. They have crystalline silicon that they actually do a whole bunch of processes, and it's very large scale integration. They have tens of thousands, maybe hundreds of thousands of transistors that are both this and FETs, FET circuits. All right, so now I've got to find IB. Do you all follow me? If you think about the analysis, right here, here's my loop coming down here. I'm going to take 10 volts, all right, minus IB, then it's going to be times, and I'm just going to call it RB, all right, don't worry about what that value is. I'm saying the 280 kilo ohms there is just RB. It's a base resistor. Follow me? Then I take minus 0.7, it all equals 0. This is a closed loop. I'm showing you the sum of the voltages around that closed loop must be 0. I didn't put all the wires connecting top and bottom. I just used the ground symbol. Everybody see that? If you do, just let me know. In the back, can you guys? Far back. Okay. So really I can say that IB here is just 10 minus 0.7 or 9.3 divided by RB. Everybody with me on that? It's this straightforward, but just watch, because this stuff you can get lost if you don't keep up. Now if I know that, IC right there is beta times IB. Can everybody follow me on that? Remember, beta is the current gain of the transistor. Beta is 120 in this case. Just a show of hands. You understand the idea? I have IB, if I have the base current, and this transistor is what's called the active region, I have IC. Now the idea is this, listen carefully. This is the collector right here. This is the emitter. What they want is the voltage between the collector and the emitter. They want the voltage across this resistor. And basically, if we're going to do this, the way it's done always is get the base current first. This is straightforward. Do you agree? If we wanted to get the base current, that's 9.3 over 280K. It's going to be small. It's going to be microamps probably. Y'all with me? Once I have that, I can get IC. IC is going to be 120 times that, which is going to be 120 times 9.3 over 280K. Then, if I want the voltage at the collector to ground, remember the emitter is grounded here. Can everybody see this, by the way? That's a ground symbol I'm trying to show you. Right there. Now, if I want voltage collector to emitter, here's what I do. I know there's 10 volts here. I'm going to do a voltage loop again, but I'm going to subtract off that voltage. So this is going to be equal to 10 volts minus the voltage drop here, which is going to be 2K times this current, which is 120 times 9.3 divided by 280K. You take one look at that, you realize the K's cancel. This is something you should pick up on when you're doing problems. Y'all see that, class? So if they cancel, I'm going to cancel. This is still 280. Now, you really have 240 over 280 times 9.3 here, and you got to subtract that from 10. I don't know what that is, but can anybody do that for me? It looks like it's going to be negative, but I don't know. Let's see. Maybe not. Can anybody tell me what that is? If you don't mind.
2.0.
What is it?
2.0285.
All right, that's still active. The only time the transistor goes into what's called saturation is when the voltage between the collector and emitter is roughly 0.2 or 0.3 volts. Varun, do you remember if they're using 0.2 or 0.3 for actual saturation?
I think close to 0.2.
They're going to use, now the thing about it is, that voltage does, here's the way they get it. They assume that actually this junction right here, this is another diode effectively, is going to be on almost, hear me on this one? So almost 0.7 volts, you should get ideally 0 volts there, but you will get somewhere between 0.1 and 0.3, typically 0.2, you said, right? And I'll get to that more. I wanted to do that problem for you. And then, as requested, bring them on up. Everything off your desk, and please spread out. I mean, there's a lot of people that have left.